All right, thank you everybody for clicking on my channel. Today we're going to be going over how to kind of make your own sort of particle containment system, which is a part of an geometry node tree that I'm releasing on Gunroad called Nebulous Containment. And this comes in a few parts, and if you've seen my Twitter, you've kind of probably seen some of the stuff that this can do. And right now, this might look pretty crazy. But this is really just broken down into 5 stages. We're just going to produce a particle field. We're then going to produce a mandala. And we're going to use the edges of those mandala to calculate the position of the points. And then use those point position recalculated, put it through a noise field. Let me zoom in. I don't know why I'm so far out. Then we're going to put that through a noise field. And then we're going to put the process of that noise field through some other math. So what this will do is it's basically going to create this very confined nebula. And I'm going to go ahead and show you some of these steps here. So step 1 is we're going to try and make this. Like, that's in the first 2 blocks. All right. And then we're going to go from this mandalic point stippling, which can also do images or any kind of mesh, honestly. We're then going to take that and turn it into nebulas, very dense, clustery nebulas, because it's using position of the curves or the edges of a field. And then we're going to learn how to take that nebula that we've made, and we're going to learn how to then contain it within another field of information so that we can use copy, 2D, 3D. Any input is fine. Multiple inputs will work good. And it can look pretty cool. This is some of the recent stuff. Multiple inputs layering. It can work with video. My previous Gumroad edition draw image also worked really well with that. And these are all things that you can just sort of make easily with this node chain. So what I have here is the main chain, and we're not going to really rebuild all of this because I gotta be honest, you don't need like 90% of what's going on here. Most of that is just so I can have all these controls plugged out into the geometry input so that we can make changes straight from the node panel. And just to kind of go over what we have here up top, we got the density of your points or your particles. So if I put that low, it reduces. I can make it 2. They're obviously disappearing. And if you push it higher, you get more of them. It's just, increasing the point density. You can change the size of the points, where you can make them small, you can make them really big. You can reduce the static or keep the static really high. And what this is doing is going to reveal sort of the clustery nebula a lot clearer. And I'm just going to hit play so you can watch this stuff animate. Then right here, the nebula lunacy, nebula distortion, nebula scale. This is just the noise texture that I looked at earlier. That's just the scale, the lacunarity, sure, and distortion. So yeah, you can just sort of distort and make things more or less crazy. You can also control the stretch on the x-axis and y-axis of your nebula within the containment, and the boundaries of how big it'll inevitably reach out before it has a maximum. And this can be kept within the containment. You inevitably need these to be larger than whatever your container is going to be. Blah, blah, blah. This is your animation speed. You can make it go quick. You can move some boundaries around. You can change the nebula style. You can change and use input collections. This is just controllers for the copy, character spacing, word spacing, all that sweet stuff. Let me just bring this to 0 for now so we can see the whole word. So then down here we have break containment, which gives a lot of cool style to how that edge is described. If I just reduce the size here a little bit and click play, you can see that as we push this value up and down, it's going to push it in and out. And you can also describe it with these 4 vector controls here. We can control the level of chaos. If I push it to 0, you can see it's less chaotic. We can control the intensity of how things are happening. So when I change this to 0, you see these breaks that push up on the edge. I changed the wrong thing. I went to position figure. If I move that to 0, you can see that those disappear. And if I push these up, you can see we get repetitive breaks, like an impact break, due to its intensity. And the position will obviously multiply how it is pushing in or out, how intensely from the copy, based on the position. And then you can also just sort of directionally move the force as well. So these are the controls I have built into this. And like I said before, we're going to go over how to do this, but we're not going to build all of this. All we really need is this. This is all it kind of takes, because if I make that invisible and I revisibilize this, you can see, golly, it tends to work. And if I were to just make this 0, you can see it's contained. So we are going to go over how to make this thing in 5 steps. I hope you're all ready. Time for a new node chain. We are going to go to this view. It's nice to have this checked on. And we are just going to delete this and just add in a new plane entirely and just zoom in a little bit. All right. First things first, we need to make a new GeoNode tree. And if you don't see it here, just hit A, and then the button that's just below escape and to the left of 1, and then click frame all selected. And this is the start of a blank node chain. And this is where we're going to begin. So step 1 is we need to give ourselves a bunch of particles. This is going to be the canvas of our universe through which we paint. In order to do that and cast a bunch of points on the face of our plane, we need to do distribute points on faces. And if we push this up, you can see it gets more dense and less dense. And right now I can actually check that off because sometimes that can be distracting. So we have our field and you can use it like this, but personally, I don't like using that. I like actually having a grid input from the node itself, because I can just control it all there in the node chain, make it bigger and smaller. And, you know, it doesn't really matter the vertices, but you do have the ability to just subdivide your mesh to your heart's content, which is very useful. So we're going to put the points back in. We're going to come back to our solid plane. And my verts are 0, so let's make those 2, and everything has returned to us. These points are kind of big, so I just want to be able to control the scale of my points. So if I do Shift-A and start typing set point, and I just, right there, set point radius, it's already done. I'm going to click it, hold Shift, and drag. You can see it gets pretty sensitive. So just get something, I think that's fine for me. All right, so we got our universe. Step 1 is done. Good job. Now we need to move on to step 2, which is describing how we're going to set each point's position differently. Because this is just kind of boring. Like, I mean, I can make it more dense, but it's like, great, okay. Let's make it do something. So in order to make it do something, we're going to need to do geometry right, set position. Okay, and if we have here, we got the selection, position, and offset inputs. And if I just move these ones on the X and the Y, you'll notice right away it's moving it positively or negatively on the X-axis, positively and negatively on the Y-axis. All the data input at the same time. Same thing as if we did actually a geometry operation, transform geometry, and translated the X and Y. It's right now the same thing. The only difference is transform geometry doesn't give us the control over every individual particle. So how we want to do that is literally you could just get a texture and just kind of plug it in somewhere. And as you reduce the scale of your texture, there you go. It's working. But this is honestly kind of boring. I'm not super impressed by this. I want to have more control over the density of clusters. One way to just quickly get more control over this is if you go to vector math, you can do a multiply add math, and as you increase the multiply, it's going to increase the intensity of the incoming noise texture. And you can just move it with add to reposition it. So this is kind of boring. This isn't what we're going to do or how we're going to do it. What we want to do is we want to think about this a little bit more abstractly by having a bit, some control over how dense and clustered that can become. Because when you just do a noise texture, it's a constant, abstract, endless field. So what I have done here is I've put in a curved circle, and I'm going to reduce the counts to something like 5. All right? And now, in order for me to get any information out of this, I'm going to need, you can do a few nodes, but I'm going to use geometry sample, geometry proximity, and plug that in. And let's see what happens if I just put the position into the position. Everything deleted. And we have a little alert icon here. So if we hover over it, we click off and hover. Is it because it's playing? There we go. I click over and hover on it. Input geometry as unsupported type curve. Okay. So that just means we need this to be a mesh. Not a problem. All we have to do is Shift A, curve, operations, curve to mesh. And now it's supportive, but still nothing's really happening here. So if I was to just look at what we're putting in here, you'll notice it has no faces. It's just edges. There's no faces to speak of, which is fine. We actually don't want the faces here because we're going to work with curve input. So let's just change faces to edges. Ooh, look at that. Now we have our shape, and we can change it, and we can increase those points there as we see fit. We're getting somewhere. This is really close, but right now my curve is kind of boring, and I want it to be a mandala just because mandalas are cool and really fun to play around with. So we're going to do curve, operations, fillet curve, and we're going to put that right before curve to mesh. It starts on Bezier. Personally, I enjoy poly. I think that's the way to go. And if you click limit radius, as you push this out, it's going to hit the maximum and stop. As you can see, we are giving a kind of a bevel, a chamfer at the where each point resides. Now, I'm going to uncheck limit radius so I can push it out and do cool stuff like this. Okay, so now we have a 5-pointed star within some other stuff, and if I increase the poly count, we can get more of a expressionary curve here. I'm just going to keep it at 1 for now. You guys enjoy, set it however you want. But right now, it's still not doing enough. So let's reiterate the fillet curve and just play with this value until we get something interesting. And then let's iterate again and play with this value till we get something interesting. And right now we're literally 1 for 1 seeing the curve. This is describing the curve and inputting all the points onto the curve, which is great for right now, because we're just going to do one more mandala extension. I'm just going to put it right there. And if we adjust our resolution, we can get really nice Mondalic expressions. And it's so nice. Very cool. Beautiful. It's gorgeous. Now, it's cool if like you want this all the points to be on the position of each edge, which is what this says. It's the position of the edge. But I kind of want this to look cooler. I want this to do more. I got a little formula here. We're going to do Shift-A, Utilities, Vector, Vector Math. And we're going to add in 2 bits of vector math. The first one, we're going to scroll in, and we're going to click from add and change it to dot product. Now, I got to thank Aaron Dale's tutorials, because it was one of his tutorials where I saw him use the dot product. And if I didn't see that, then I would have never thought to even gravitate to it. But I feel like this makes sense. You know, we have a lot of dots, and maybe calculating the product of them could do something clever for us. And what we're going to want to do is we're then going to want to combine the dot product with divide. And this is going to do something really cool. I'm going to plug position into the top socket of divide. I'm going to plug distance into the top socket of dot product. And then the dot product at the bottom of the divide. And now let's plug it into the set position. Let's try offset first. All right. So if I did it on the position, right, we just get the 1 point. If I did it on the offset, it looks like nothing is happening. Well, that's because this vector here is 0. So if I increase this, you'll notice we start describing what's happening, right? This is getting really cool. So if I say 0.01 and I increase to 2000, I don't know, just put it somewhere, whatever you think is right, we can just see some really fantastic expressions of our shape here. And now we are done with stage 2. That's stage 2. And if you get kind of annoyed with like how these are scattering out so like endlessly, whether you're negative or positive is going to greatly, it's either going to push to the position or it's going to push away from the position of the globe, which is like where X and Y meet, right there. You know what I'm saying? Okay. So, I'm going to take a quick second. Hang on. All right, and I'm back. I had to go deal with a thing, so I'm now in the future, and I don't remember what I was exactly last saying, but we've got this dot product here, and just a couple quick things about this setup right now is, first off, for the rest of this project, we're going to be zeroing out pretty much all the z-axis, with the exception of one thing, which I'm actually going to get to in a second. So this is just going to make our experimentation easier because we have just one less value we need to think about as being a contributing element. You just have the x or the y values that we're working on, okay? So pushing and pulling these values here is going to push and pull the distance and of the particles based on the distance of the curve divided by the position. And if you want to get rid of all of these excess stray particles, you can do a geometry operation, transform geometry, and put it right here is fine. You can also put it before curve to mesh, doesn't really matter. Anything that's like in this chain. And if we push this up on the z, I know I said no z's, only way we're doing a z, you'll notice it's going to do a thing where it really clamps what's going on. Okay, like you'll see it gets a really strong clamp. So if you want to play around a little bit with this, best way to do that is just start with your vector maths. I'm just going to pull out a divide here, change it to multiply add. And this is the best way I go about experimenting, is we've got a number of used inputs. And if I plug the position in, if I plug this into the position as well, we also get another form of containment. Okay, so, but I like the appearance of offset right now, and we're just going to keep it like that. And even if I adjust this control, that's our artboard, which, as you can see, is influenced by that. Yeah, so let's just take this multiply add. This is kind of like my best friend. checking stuff out. And what I do with my node chains is I'll just plop it in. I'm just going to make that set to 1 so that it's not changing anything. I would plop it in before, and I plop it in after whatever sort of function is happening. And we're just going to see what happens as we sort of adjust these parameters here. All right, looks pretty similar. Okay. You know, it's all pretty similar. So what if I adjust it here? You can see it makes, different changes. So add here does a lot of cool, interesting work. I'm going to bring that back to 0. Multiply seems to be doing the same thing as this vector here. And if we multiply after, it's adjusting the intensity. And, you know, I feel like it's giving more opportunity for description, but not necessarily like super important, I would say. As we adjust the position multiplier, we can definitely bring more change here. As we add, we can, I guess, push the directions up and down on the X and Y axis. Just going to center what I got going on here a little better. So here's our mandala. And if I do this, you can see that we're pushing the full value entirely. And a lot of the multiply add seems to do the same. So I'm just going to pull all that out. You're more than welcome to experiment and bring in all sorts of other fun math functions, because there's a lot to sort of look at here. And you can sort of play around with plugging any of these in and then bringing a multiply add on either side of it and just sort of tweaking its intensity. And you can really make a lot of fun sort of like play with your stuff. And, you know, the more you push this is changing all of your expression with your mandala. So it's just pretty cool. I've got no complaints with it. Okay, so we've got our mandala. Beautiful. Next step is we want to use this mandala to contain our noise field. So we're going to bring in our noise texture. We're going to plug it right in there. I'm going to make it 4D. So what that does is this gives me a W slider that 3D doesn't have. And this basically just lets me sort of move the texture without changing anything. Like it's just kind of moving it within a field space, which is the same thing as if I was doing this, adjusting the add of its position slot. And I've also got a multiplier here, which will multiply the position's intensity effect, which is kind of the same thing as doing scale. It pretty much the same. But, you know, we can make scale less intense, more intense. We can increase detail. We've got like some of like whatever that word is called, and we can distort it even more. Pretty cool stuff. But this isn't really making a nebula. This is just sort of adding chaos to the mandala's design. So what we're going to do is I'm just going to make another vector node here. Just set that to 1 for now. And of course, true to form, we're going to be doing some multiply add in between some things. So I'm going to want to multiply this power, you know, which is going to make it really intense. And as you can see, because I can uncheck that, and it's going to sort of zero out itself, but I like having the normal function. So one way to keep this from doing that is actually, if you want to just sort of center this, you can do a simple value node, plug it into there, and then plug it into the add. But where it sits in the add, if you do a math node and do a multiply by -0.5, so it is, you know, not going to move now. And now it's centered on the center point. Just a nice little helpful tip here, keeping things from getting too chaotic in your own experiments. I don't really need it right now. So I'm just going to unplug that, and we're going to put it right there. Because what we're going to do is we're going to contain the field, because if I were to just keep pushing this, you see how it just sort of goes out forever? I don't want that. I want it to go to a certain point and then come back. And generally, how you limit that is with a sine wave. So we're doing a sine wave. And now if I do, you could see it's going to some sort of barrier and then returning, right? So essentially what's happening is a sine wave is like a cube field, and wherever it hits from like 0 to 1 on the calculation, so this would be like 1, 1, negative 1, negative 1 on the x and y, and 1 to 1, I mean 1 to negative 1 on the z-axis. And so wherever it hits that limit of 1, it's going to push it back again, and then it's going to keep pushing it and pushing it forever. So I'm going to reduce this strength here a little bit, reduce the scale of that intensity. And so that's like kind of the first containment, but it's not really giving me anything too different. And what I'm actually going to have this go through first is an absolute. Don't get too scared. Okay, we're going to adjust the value going in and adjust the value coming out. Ah, yes. So we are getting something happening. Look at this. All right, you see how it hits this sort of point? And I can push it forever in these other directions, but it's not getting pushed anywhere in that direction. But if I set this a little differently, you see we're kind of moving it and sliding it. And I think part of this issue is, let me zero out my x-axis, and I think this is going to be a little bit more sensical for me. All right, so if we multiply the input, we can see really where it's hitting its termination and where it's going to start pushing back on itself. If I multiply this input again, we can see we get we're multiplying the intensity of the effect coming out. I feel like at this point, we can plug this into the position. And look at that. We've got this very interesting looking cluster starting to form. A sort of cloud appears. Now, there's a few things we can do to clean up this cloud. We can do the curve on the z. We can reduce the scale. We can change some of this multiplying input. We can make it bigger. We can make it smaller. And I'm going to move this down on the z and just kind of multiply this a little lower. And you see how I'm having a problem here? All right, this is my first problem, is I need to contain this even further. And we're doing this by not an absolute function, but a sine function, so that we can create a field of 0 to 1 that it's going to be contained with. So if I slide this here, you'll notice it's only going back and forth in these fields. Okay, this is going to keep it from getting too crazy, too lost, too out of whack. So now we can increase it here. Let me turn that off so we can actually see the particles nicely. We can just adjust our noise texture right now and look at the interesting nebulous we have here. And just as we move our multiply add, we can definitely bring a lot of chains to its position. And if we slide the W value, you'll notice that it's animating this rather interestingly. And one way we can just have it do that on its own is adding a scene time node, plugging the seconds into W and hitting spacebar for play. It's a little too fast. I'm going to add in a multiply node and just multiply it by 0.2, which is the same thing as dividing by 2. Still a little too fast, so I'm going to do 0.05. And now we get something slower, more romantic. Here is our nebula. Now, if I were to pause it, I could just Shift D the whole chain, RX 90, and hit play, and we've got some interesting stuff happening. And you can get pretty artful from here on out, and just spend a good amount of time having fun with these few nodes. You know what I'm saying? Just these nodes right here. So if I'm multiplying the absolute out, which is going into the sine, which is our sine in, it's going to just make it hit the walls more. And if I make it smaller, they hit the walls less. The whole item becomes smaller. As the whole item becomes smaller, it hits less wall. As the whole item becomes bigger, it's hitting more wall, which creates this sort of sine rippling push and pull effect. Okay? Now we have our sign, and true to form, multiply add after, and I'm just going to zero out the add, and we are just going to see how we can control the size of our box now. All right, we're just going to keep it here. Pretty similar to our camera size. Not bad. Now we have this cool sine wave nebulous function with very contained, dense sort of nebulas, which is all based on a Mondalic curve. And, you know, you can bring changes to it from that curve. So the next step we got to do is, now that we have our nebula, I'm going to delete one of these. Make sure I didn't delete the one that was rotated. Okay, I didn't. Good. All right, so we're going to take one of these. And now that we have our nebula, we need to contain our nebula. So how we contained particles before was using dot product into divide on the edges into a set position. We're going to do something really similar. We're going to shift D our set position. We're going to shift D our geometry proximity, and we're going to shift D the dot product and our divide. All right, a couple things we're going to do differently though. Our input here is going to be a little different, and for the sake of this tutorial, we're going to do copy. So I'm going to hit Shift A and type in string. Okay, this is just a field for us to type in. Hey. There we go, I said hey. And now we need to have this do something. So if I just drag this out and let go, you can hit, the first one is strings to curve on mine. You can either type that in, whatever, and that's what I need. So this is going to turn my string and make it font. It's going to make it font. And so I can plug that into here and to my geometry proximity. So right now, nothing's going to happen if we don't select a font. And if you click font and nothing's popping up, come over here and import your font from your computer. Go to your fonts and bring in your favorite. And I'm just going to center all of this stuff, middle, midpoint, just so it's very centered. And I think that's good enough for right now. So if I take this and true to form, plug it in like this, like that, and go over there into the offset, nothing's changed. And that's because we're getting an alert. Curves are ignored, and instances have not been realized. And what that means is this is a set of instances that it's putting out as curves. So we need to change our curves to meshes, and you could do operation curve to mesh, but that's not going to change our, it's not going to give us any faces, it's just going to give us this outline. And what we want is we want to contain with a face, which will give us a broader sort of spread rather than just containing it on lines. So two things we're going to do. We're going to change geometry proximity to its faces. And now we are going to go to curves, operation fill curve, and switch that to n-gons. And now we're going to do Shift A, instances, realize instances. Okay. So now we've got something happening, but it's not really doing too much. One thing we could do is I could zero that out, and you'll notice if I push those numbers, we're getting something going on. It's not super pretty. I can increase the size of hay, and you'll notice, yeah, we see a little bit of the Y here. We're getting some other weird stuff happening. Okay. I do want to check if I just move our field around a little bit. Okay. So if we stretch our field, okay, and we just broaden it out, we can see our words. All right. We've made our canvas big enough to read our copy, and we can now see our copy stretch in and out. So if we just change these dot product values, you're going to notice they kind of go, they're doing some stuff. It's not super great. So we're going to change dot product. We're going to change dot product to a cross product. And we're going to plug that in. I'm going to zero these out. And the next thing we're going to do is we're going to change offset to position. And we're going to change the top one to a negative number. And that looks too big, so we're going to do negative 0.1. And then we're going to do 0.1. And let's see what we got going on here. Now, we got some crazy stuff happening, so let's slide these around. Okay. And, you know, not super controllable yet, so let's repeat our form of multiply add and multiply add. Let's just make that 1 for now and make the output 1 for now. And interesting. What if we change add? Oh, we're getting something. Beautiful. If add before does nothing. So the add export after cross product is the most important part. And if you'll notice, I'm taking this multiply, and it doesn't seem to do anything when I change these values. But then without it, we get lots of craziness. Now, this is what's happening to the edge of the copy. And this is going to be your two values right here are going to be pushing and pulling the edge of your copy. And if I set that to 0, you're completely clamping it. So, I mean, we've kind of done it. If I hit play, it's animating. If I set this to 1, I could also set these to 0, and it would do the same thing as multiplying by 0. I can just kind of play with these and stretch some stuff out. And that's basically the whole thing. The only thing I did differently from here on out is I wasn't super satisfied with how this looked. So I brought in a dot product again, plugged that into the top vector. And this gives me an extra way of describing what's going on. The X and Y seem to do the exact same thing. It's going to give more of like a straighter push. This is going to give more of like, now it looks like it's doing the same thing. So let's just check our multiplies here. What if we multiply one of these values and it's doing cool stuff? Pretty cool, you know? And we can push this out farther, push it in. If you feel like these are too broad, let's just change our container. And you'll notice if we change the size of our container here, we can describe how much of that gets pushed out. So this here is the gist of it. And it's not like super cool, because a lot of this looks kind of boring. And the real difference of what happens is if I go back to this other chain here and we look at this function, you know, I even have dot product pulled out. Let me just make those do something. And then we multiply the function coming out of it and we have it going into its position. Yeah, so, you know, let's just do that again. And multiply the function coming out. Zero out the add, and let's make these the same. And now you can stretch the whole field, and you can stretch the whole field. And you can bring more drama. So when it comes to this, the difference between what this is and what this is literally comes down to just going in between these nodes and just trying some stuff out. You know, just like experimenting, like throwing in multiply add and just plugging random values into it and just multiply adding the intensity of those values. And if it looks like nothing's working, well, if you've got this group of functions, you're going to need multiple, you know, data drivers, like just multiplying its you probably need like another function against it. Same thing with modulo, same thing with snap and warp. You know, it's really gonna come down to how much you can experiment with this. And I feel like there's a lot of room to build and have some good fun. So I want to say that that's like pretty much it. Like you really just got to kind of like have fun and explore different stuff here and see what kind of crazy you can make. All right, I'm throwing in that dot product. Let's push it here. Let's get a multiply add in. And then the add vector here is what made something go. Yeah, so we're just going to push it in a little bit. We're going to multiply the y. And we're going to multiply the x. And it gives this like nice, just cool sort of chaotic expression. And you can even like probably take all this and then like multiply it from there. And actually, wait, what if I put that in the dot product? Yeah, now look how cool that is. And look at that, that was just like a fun guess. Who knows what cool stuff you can plug and play with. Have fun. I'm just kind of rambling right now. So check out the file on my Gumroad. The link is in the description. Thank you so much for tuning in for this long. And we're going to end the stream and recording right now. So have a great day.